Hello students, this is Mr. McAllen speaking, and we're on Unit 6, Day 9 of our flipped classroom, where we're working with radians. Now today what we're going to be working on is finding complements and supplements of angles and radians. We're going to find coterminal angles for angles and radians. We're going to try to convert degrees to radians and try the backwards conversion. And what we're going to first start off with is complements and supplements. Remember in degrees that for complements, the two angles have to add up to 90 degrees. While in radians from yesterday, if that's 0 radians, when we're at this point of the circle, this is about 1.5 radians, or you would say pi over 2 radians to be precise. If you're at 180 degrees, you would say that's pi radians, or approximately 3 radians. So when you're talking about a complement or a supplement, complements are angles that add to 90 degrees or to pi over 2 radians. So complement are angles, two angles that add to pi over 2 radians. So if you wanted to find the complement of an angle, it's pi over 6. So here's my angle A plus what I'll call is the complementary angle. It's got to add up to pi over 2 radians. So all you have to do is you just plug in the angle A of pi over 6, add it to the unknown, the complement, you should get pi over 2. We solve for that angle by just subtraction. So pi over 2 radians minus the pi over 6 radians. And then you have to do a little bit of work with fractions. So you have 3 pi over 6 radians. That's just pi over 2 converted. And pi over 6, that's the original angle. And that would equal what your complementary angle is. And this ends up being 2 pi over 6, which equals pi over 3. Now, let's just check that out with our rough estimates from yesterday when we were talking about how far a radian approximately takes you around a circle. We know that at the 90-degree position, we're at about approximately 1.5 radians. The angle that they gave us was approximately equal to 3 over 6, because pi is approximated to be 3. So we had roughly 1/2 of a radian. So that would put us at right here. This angle would be 0.5 radians. So my complement is the remaining angle to get to 90. And that would be equal to 1 radian as an approximation. Checking that answer against this answer, you could see that they correspond because pi is approximately 3 and this is approximately 1 radian. To find the supplement, you would be doing the same sort of work, except supplementary angles add to 180 degrees. Now that corresponds to pi radians. So we would do the same sort of work we did before. We would take, instead of calling this angle C, we would call it angle S for the supplementary angle. They would add up to pi radians. We would go through and do the same sort of work we did before. We would just say our angle plus our supplementary angle should add up to pi radians. We need to convert this to over 6. So I have pi over 2, which is no longer there. This is now pi minus the pi over 6. My common denominator is going to be 6 pi over 6 minus pi over 6 gives me 5 pi over 6 for my supplementary angle. And when you simplify 5 pi over 6, well, actually 5 pi over 6 is fully simplified. Now let's check that out with our rough estimates. We have 0 radians. We're trying to get to 3 radians because 3 is approximately equal to pi. So the first angle was 0.5 radians. So the supplement has got to be 2.5 radians. So if you check that out, 5 pi over 6 is like 5 times 3, because pi is equal to 3, divided by 6, which equals about 2.5. So my answers correspond. Hopefully this helps making doing your work for supplementary and complementary angles easier for estimating them, but we do want you to do the work that requires you to find the exact value. To find coterminal angles for any angle that I give you. Coterminal means that if you take the angle, just like we did before, and you add or subtract multiples of 360 degrees, but in this case it's 2 pi, you would get the coterminal angle. This is something that we did earlier in this unit, and we quizzed on it for when we were in degrees. So all you have to do is add or subtract the multiple of 2 pi. So based on the angle I give you, you find the common denominator. So this would be 4 pi over 2. So your coterminal angle would be pi over 2 plus or minus 4 pi over 2, which is like saying 5 pi over 2 or negative 3 pi over 2. Now we're moving into the next objective, which is to convert 300 degrees to radians. So in most classes where you have a conversion factor and you do unit conversion, you need to know what one thing is equal to as opposed to the other. So we have pi radians is equal to 180 degrees. So whenever you're going to convert, for example, if you go from degrees to radians, the conversion factor would be pi over 180 degrees. So this is your conversion factor. So if you're going to convert 300 degrees to radians, you would have to set up your equation like this, where you take 300, you multiply it by pi over 180, and then you would have to simplify. So again, this would equal, the common factor would be 60. So I would divide 60 out of both top and bottom, and I would end up having 5 pi over 6. If you want to try another example, let's say that you're converting 240 degrees to radians. So I'm going to leave that, I'm just going to write up the 240. What's your conversion factor? And that should equal your radians. I'm going to pause the video and let you try that on your own. Okay, so we took 240, we multiplied it by the conversion factor. We got 240 pi over 180, and our exact radian amount would be 4 pi over 3 after dividing out the common factor of 60. Last task for today is to convert 5 pi over 6 radians to degrees. So this is the reverse conversion. So when you go from radians to degrees, you need to take this conversion factor from before and use a reciprocal. So we're going to use 180 degrees over pi radians. And so the radian amount would be, in this case, 5 pi over 6. And then that's going to give you your degree amount. If you notice, we get 5 pi times 180 over 6 pi. And the pi's cancel. And you end up having 5 times 180 divided by 6. And the units of degrees are still are there. So this is going to end up being 300 degrees when all the canceling is taken care of. So hopefully this lesson or this video has helped instruct you on those 4 objectives through these example problems. And in class, we're going to practice a whole variety of these when we see you on Monday or the next day we meet. Have a good day and look forward to hearing your comments.